Hey guys, this is a 1.3. It is an introduction to polynomials. So we'll do some polynomial vocabulary. We'll add, subtract, and multiply them today. If you are having any concerns or are on the fence about tutoring, I would say schedule some tutoring right now. And that way you can kind of get in the swing of the course material because this is going to be foundational to everything else that we learn in the class. And more tutoring up front will expedite your way through the class as opposed to trying to go through it alone. That would generally take a lot longer. And then if you miss something, you'll have to like backtrack later in the course. So the fastest way through this, if you have any confusion, is to start tutoring as soon as possible. And again, there are tutoring resources in our Blackboard that are pretty open to various schedules and modes of tutoring, including online tutoring that does not cost anything. All right, let's get started. All right, I just moved my microphone around, so sorry if it sounds different. This should be the sound for the rest of the video. You need to adjust it. Before we go over the vocabulary, I just want to show you what we're starting with. So here are the notes. And the reason I put the vocabulary up front was just because this is a lot right now. That formula looks very confusing to me. So yeah, this can look overwhelming. Don't be overwhelmed. And then we have terms like monomial, binomial, trinomial, degree, coefficient, variable. So I just wanted to go over those before we actually started the notes. This should be the first couple pages of the notes that are on our Blackboard, but you're also welcome to handwrite anything that you need to know if you did not print this off. All right. So for polynomials, for working with polynomials, it's essential to have the right vocabulary. Today, we're going to define term, coefficient, variable, degree, and polynomial, standard form, leading coefficient, constant term, monomial, binomial, and trinomial. Terms are the building blocks of polynomials. Each term is made up of a coefficient, a variable, and a degree. Here are terms. The term is, for example, 3x squared is one term. X to the power of 5 is another term. Negative 2x to the 12th is another term. 1/2 times x, or 1/2 x, is a term. And even just the number 17 when we're talking about polynomials can be a term. Okay? Terms do not include plus or minus signs. It says that they include multiplication. Why does it say that? Because the -2 right next to the x means we're saying -2 times x. Good? That's multiplication. So they're also adding, this is not important, and we will also go over this here, monomial. Monomial is a polynomial with only one term. Okay, so monomial is right here. A solo term is a special kind of polynomial called a monomial. So terms are something like x to the 5th, -2x to the 12th, 1/2 x, 17, or 3x squared. Good. It has a coefficient, a variable, and a degree. Coefficient the coefficient is the number in front of the variable. Good. So these are all going to connect. I know this is a lot of new words, but I want you to see how they connect. A term is made up of a coefficient, a variable, and a degree. It does not include the plus or minus sign. You might be thinking, but that one has a minus sign in front of it. The minus sign is a negative sign when we're talking about terms, okay? If we had x to the 5th minus 2x to the 12th, that's a positive x to the 5th and a negative 2x to the 12th. The two terms are x to the 5th and -2x to the 12th. You don't need to put the plus and minus sign in. Those are not individual terms. They are just telling you whether that term is a negative term or a positive term. Good? Okay, so on to coefficients. The coefficient of a term, right? Remember terms in purple, blue, I guess. Coefficient coefficient of a term is the number. Okay? If you have 3x squared, 3 is the coefficient. Okay? For x to the fifth, well, before we move on to that, the coefficient of a term is the number. For 3x squared, 3 is the coefficient. 3 is the coefficient. Negative 2 is the coefficient. 1/2 is the coefficient. We'll skip 17. Good. The coefficient is the number in front of the letter. Good. Now, what do they have to say? I'm going to put it in brackets when it's just like a little bit extra, right? Not the key material, but something that's good to understand. For the term x to the fifth, the coefficient is invisible, but you can think of it as 1, right? X to the power of 5, you're multiplying x to the power of 5 by 1. 1 is the coefficient. So we can say x to the fifth is the same as 1x to the fifth, which is the same as 1 times x to the fifth. Okay, so it's just something to understand, not essential. The coefficient, when there is no number, is 1. Okay? The coefficient is 1. For x to the fifth, the coefficient is 1. If you have just the number is the coefficient. Okay? Now, variable, this is going to be very important for our entire course. The variable is the letter that represents a number that we don't know. You're trying to solve for something, you're trying to solve for a number, you don't know what that number is, you're not going to put in, right? You're not going to put in 3 question mark squared. You're going to say 3x squared. I don't know what that number is, so I'm going to put a letter in for a number. So variables are letters that represent numbers. Guess I need a new color now. We did coefficient, variable, variables are letters that represent numbers. The letter we use for a variable most often is the letter X. The degree of a term, oh shoot. Okay. Hopefully I add it back for yours. But here we're going to add in degree. We've moved on from variables. That's all you need to know about a variable. It's a letter and it's in place of a number, and that's why we solve for the variable. We solve for x because we want to know what that number is right next to 3. Good? All right, degree. The degree of a term, so we got variable. And moving on to degree. Okay. The degree of a term is equal to the number that the variable is raised to. If the term is 3x squared, the degree is 2. For the term 17, oh, that's extra. For the term 17, the variable x is missing, right? So for 3x squared, we see that x is the variable, it's being raised to 2, so the degree is 2. For the term 17, the variable x is missing. The only power you can raise x to where it will disappear is 0. So the degree is 0. The degree of a number is 0. Why is this true? Because x to the power of 0, I won't use x, I'll use the letter e. E to the power of 0 is 1. 100 to the power of 0 is 1. Anything raised to the power of 0 is 1. That's why we can say that 17 has a degree of 0. because you can look at it as 17 is equal to 17 times x to the power of 0. Because x to the power of 0 is 1. 17 times 1 is still 17. And remember, when they're right next to each other, it means we're multiplying. 3 is being multiplied by x squared. 17 is being multiplied by x to the power of 0. So that degree is 0. Also, degrees are never negative and never a fraction. Okay? We did see a fraction up here, right? The coefficient can be a fraction. The degree cannot be a fraction. So let's color these. That's the degree. That's the degree, right? That's the degree. That's the degree. For 1/2 x, the degree is 1. One half times x to the power of 1 is the same as 1/2 times x, right? Like if we had 1/2 times 4 to the power of 1, we're going to get the same answer as if we had 1/2 times 4. So when you see that 4 was standing in for x in that case. So when there is no number up there, you still have the variable, but there's no number. The number is 1, understood to be 1. When you don't even have the variable, it's just 0 to the power of 0 because it is 1, okay? All right. There it is. Uselessly. All right. When you are asked to combine like terms, you add or subtract the coefficients of terms that have the same degree. For example, 3x to the fourth minus 8x to the fourth can be combined together because they have the same exponent and degree, right? We see x to the fourth and x to the fourth, so we just take 3 minus 8. Those have the same degree and the same exponent, or sorry, they have the same exponent and they have the same variable, so you just subtract them. 3 minus 8 is a -5. X to the fourth. Good? All right. Now we're at, finally, what is a polynomial? A polynomial is a collection of terms. Hold on, I want to pause this before I start flipping my paper. All right, I wanted to continue the theme of colors. So a polynomial is a collection of terms. Remember, a term is just everything between the plus signs or the minus signs, okay? A polynomial is a collection of terms connected by addition. You can create a polynomial by combining all of the terms introduced above. So here we have an example of 3x squared plus x to the fifth plus -2x to the 12th plus 1/2 x plus 17. So all the terms introduced above or on the other page were this list, right? So we combined them by putting plus signs between them. We took a bunch of terms, we put plus signs between them, we got a polynomial, right? To put a polynomial in standard form, combine like terms, right? If they're alike, you put them together into one term, combine like terms, and then sort terms by degree, highest first. Okay, remember that for the degree, we're looking at the exponent. Here we have x squared, x to the fifth, x to the 12th, x to the first, x to the 0. That's understood, right? You can imagine that there's a 1 here, or you can just call it x. You can imagine that this is an x to the 0. Combine like terms and sort terms by degree, highest first. So notice that instead of 3x squared, to put it in standard form, you're going to put the biggest degree first, followed by the next biggest, down to if you have a constant is what 17 is called because there is no variable, okay? Now, notice that right here, we have the addition of a negative term. The addition of a negative term is the same as subtraction. So right here we had plus -1/2, and we just called it -1/2. Okay? The degree of a polynomial is equal to the degree of its highest degree term. Good? So first, let's come back up here. Well, it's all the same term, right? Degree, I'm just going to list the degrees. Degree of 2. Doesn't matter what number is in front of the x. This is a degree of 2, degree of 5, degree of 12, degree of 1, degree of 0. Okay? Now, we've put them in order. Now we have 12, degree of 12, degree of 5, degree of 2, degree of 1, degree of 0. The degree of the entire polynomial is, you've put them in descending order from 12 down to the smallest, and the highest one is the degree of the polynomial. This polynomial is degree 12, okay? The whole thing has a degree of 12. And I'm just rewriting it, but because the leading term, or the biggest degree, the leading term has a degree of 12, or the biggest degree is 12. Good? Same thing. Once you have put it in descending order, remember coefficient. What is coefficient? Coefficient is the number in front of the x. Okay? You can even add that. The number in front of, I'm just going to say x, but it's in front of any letter. The coefficient is just the number in front of the letter. The leading coefficient is the coefficient of the highest degree term. So remember, we didn't put it in order of 3, 2, or 17, 3, 2, -1/2 because those are coefficients. We put it in terms of the degree. 12, 5, 2, 1, 0. And now the leading coefficient can be found by taking the number that has the biggest exponent and the term that has the biggest exponent and figuring out what number is in front of the variable, right? So we've put it in order and we said this has a leading coefficient of 2 because 2 has the biggest exponent, right? 2 is being multiplied by the x with the biggest exponent. Now, a constant term. The constant term of the polynomial is the term with no x's, degree 0. The constant of this term is 11 because 11 does not have an x, or as we talked about, it's 7 times x to the power of 0, or sorry, 17 times x to the power of 0, which is just 17. So the constant is that last number, provided that it does not have a variable. Good? Okay. Some notes. We're almost done. Some notes about polynomials. This is pretty straightforward, I think, but it is basically that if the polynomial has one term, it's a monomial. Monomial has one term. Binomial has two terms. Trinomial has three terms. Good? Oh, ignore all of this. You do not need to know that. You won't hear about that. Okay, but those are good examples. Polynomials with more than three terms are just called polynomials. There aren't special names that we're going to use for them. Okay, so I'm going to give you an example of a monomial. A monomial is something like 17 or x to the fifth or 6x squared. Okay, those are all monomials. Binomials are these two examples. 3x minus 4 is a binomial because there are 1, 2 terms. X plus 10 is also a binomial because there are 1, 2 terms. Trinomial has three terms. 2x squared minus 3x plus 10. That is a trinomial because there are 1, 2, 3 tricycle, bicycle, monorail. Um, Also notice that this is already in descending order. Here's the biggest degree, and then here's the constant. Starts with the biggest degree, ends with the constant, if there is a constant. All right, those are the notes we need to understand before starting this assignment. 3.1 polynomial operations. All polynomial functions are of the general form. And then we have a sub n times x to the power of n, a sub n minus 1 times x to the power of n minus 1. It's confusing. What you need to, or what you know what, you can just tune me out right now if this is overwhelming. So here's our whole term, right? 1, 2, 3, 4. We have 5 terms, right? What about coefficients? Our coefficient is that a sub n minus 1, a sub n minus 2. And I'm saying that you can tune this out right now because I think you'll still understand it, even if you don't understand what I'm doing right here. So if you're already like, no, please stop, you don't need to fundamentally understand what I'm doing right here. So each of these is a term, 1, 2, 3, 4, 5 terms in this example. Those dot, dot, dot means that there could be a lot of terms between them, but on this paper, we have 1, 2, 3, 4, 5 right now. All right, 5 terms, the coefficient. The variable is x. So the variable is the same throughout the polynomial. And then we have the degree. What I want you to notice is how the degree is descending. N just means number, right? So a number for the first term, that number minus 1 for the next term, right? So maybe it was 12, 11, 10, until you get all the way down to 1 and then 0, okay? That's what they're trying to say with this polynomial formula, I guess, with this form. N is a non-negative whole number and a of n is the coefficient for the associated variable, right? So we know that a of n is the coefficient and n we said was the degree. And remember we said that the degree is not going to be a fraction, so it's a whole number, and it's not going to be negative, okay? Let's begin. Using what notes we have, we are going to determine whether 1, 2, 3, and 4 are monomials, binomials, trinomials, or none. All right? Remember, monomial means there is one term. Binomial has 2 terms. Trinomials have 3 terms. And if it has more than 3 terms, it's none of those 3 names that we just say it's a polynomial. Okay? Then we're going to identify the degree and the leading coefficient. Degrees of the polynomial is equal to the degree of the highest degree term. So here we would say this polynomial has a degree of 12. The leading coefficient is the number in front of the variable for that very first term. Remember, if there is no number, we say it's 1. Good? All right. So first, let's say whether it's a monomial, binomial, or trinomial. Monomial has 1 term. Binomial has 2 terms. Trinomial has 3 terms. I'm just going to highlight them because this page is small, getting a lot of filling it up. All right. So we'll do that before we identify the degree and the leading coefficient. How many terms do I have? Here's my first term, second term, third term. So that is a trinomial. There are 3 terms. Good. I went back on what I said. I'm going to write it too. 5 minus 19x, or 5 plus negative 9x. Those are two terms. So we're going to say that's a binomial. Here we have 1, 2, 3, 4 terms. Each term is separated, right? We separate terms by the plus sign or the minus sign. So we have 1, 2, 3, 4. So we're going to say that's none of the above. It's bigger than 3. And finally, here we just have the number 6, which, if you remember, is called a constant, but we can also call it a monomial. All right, so next we're going to identify the degree and leading coefficient of the entire trinomial, okay? First thing you want to do is put that exponent in descending order. n, n minus 1, n minus 2, 1, 0. Here we have 15y to the third plus 8y squared minus 6, so it's already in order. The leading degree, 3. Good. Next, remember, descending order. Here's x to the power of 1. Here's x to the power of 0. Remember that 5 is the same as 5x to the power of 0. Just another way to write that. X without a number is just x to the power of 1. 1 is bigger than 0, so we're going to flip those around, and we're going to get negative 19x plus 5. Five minus 19x is the same as negative 19x plus 5. Notice, always in this course, that the sign in front of the term goes with the term, okay? There's no sign in front of 5, so it's positive, but there's a minus sign in front of 19x, so it's negative 19x. So when we move it, when we switch their places, switch the order, it's a negative 19x plus 5. Good? So it has a degree of this had a degree of 3. This has a degree of, what do you think? What's the biggest degree in negative 19x plus 5? Degree of 1. X to the power of 1 was the biggest exponent there. Good. Here we have negative z to the fifth minus 9z to the fourth minus 2z to the third plus 12. It's already in descending order, 5, 4, 3, 0. Good. So this is a degree, no, we need to move it around, degree of positive 5. We'll never have a negative exponent. And you're just taking the degree that is the biggest in the polynomial. Good. For a monomial, remember, just like 5 became 5 times x to the power of 0, 6 is the same as 6 times x to the power of 0, so that's a degree of 0. Last part of the question is, what is the leading coefficient? I need to change colors because I'm out of space. Leading coefficient is, what do you think? 15, 8, or negative 6, and why? It's 15, not because 15 is bigger than 8 and negative 6, but because 15 goes with the biggest exponent. Good. We switched it to negative 19x plus 5. So our leading coefficient is 19. Here, what did we learn when there is no number? It's just a 1. but there was a minus in front of that z, so it's a -1. That z to the fifth is being multiplied by -1. Here, leading coefficient, just 6, because that's all we have. Good. 15, -9, ooh, I apologize. -19, -1, and 6. All right, let's go on to 5. Adding and subtracting of polynomials boils down to simply combining like terms, which we saw in the example. When combining like terms, you do not change the exponents of the variable. So here was our example of combining like terms. When you're asked to combine like terms, you add or subtract the coefficient of terms that have the same degree. So that term, x to the fourth, has the same degree as that term, x to the fourth. So 3 minus 8 is -5. You do not change the x to the 5. Good. All right, let's add for number 6. We have 4x to the third plus 4x plus 8. And we're going to add that to the quantity 5x squared plus 3x plus 3. You have parentheses. You don't need to do anything about the parentheses because you're just adding, right? So I'll rewrite it without the parentheses. 4x to the third plus 4x plus 8 plus 5x squared plus 3x plus 3. Now what I'm going to do is I'm going to look for like terms. Remember we talked about like terms? Here, 4x to the third. Do we have anything else that's x to the third? We do not. Nothing to combine that with. Then we can go on to plus 4x. Remember to always include the sign in front of it. Plus 4x is the same as plus 3x, right? And then we've got plus 8 will be the same as plus 3. And then we have plus 5x squared. There's no other x squareds. Do you see why those all are like terms? And I'm going to rewrite it in that order so that it's easy to combine the like terms. Plus 4x, and I'm going to move that 3x up so that we can combine them easily. Plus 8 plus 3, so we can combine the 8 and the 3, and then plus 5x squared. Good. Now we see that these two are going to go together. And we see that these two are going to go together. So that becomes 4x to the third plus 7x plus 11 plus 5x squared. Now all I want you to do is put it in descending order, okay? So our final answer is going to be 4x to the third plus 5x squared plus 7x plus 11, because that is in descending order of the exponents. 3, 2, 1, 0. That is our final answer. Here, subtract the polynomials 18x minus 5 minus -12x plus 3. When you're subtracting, parentheses do matter, okay? Down here it says when you subtract a polynomial, you must change all the signs to the polynomial on the polynomial getting subtracted. Okay, I'm going to put it down here. I'm going to write number 7 down here. Let me just write it right here. So that you can see what we have to do when it's... I was thinking minus. And so I wrote a minus. 18x minus 5 minus negative 12x plus 3. So when we were just adding, right, it was like plus 5x squared plus 3x plus 3, right? We just plus 5x squared plus 3x plus 3. All of them were positive, so nothing's going to change as we distribute that plus sign, right? Now we're distributing a negative sign. So we're going to take 18x minus 5 and we're going to subtract negative 12x and we're going to subtract 3x. How do we do that? By distributing this minus sign to those last two terms. Okay, so that becomes 18x minus 5. I don't need these first parentheses because they don't do anything. There's no sign or number in front of them. Minus negative 12x minus positive 3. So I've now distributed that minus sign. Now I'm going to simplify it. 18x minus 5, a negative followed by a negative, or negative times a negative becomes a positive. 12x minus 3. Or you can think of that as a minus of plus 3. Negative times a positive is a negative. Good? So now we have 18x minus 5 plus 12x minus 3, and we see that we have some like terms. So the most important thing to understand from number 7 is how to distribute the minus sign, which we just did. So we have a positive 18x and a positive 12x. And we have a negative 5. Don't forget to always include the sign when you're moving them around. So now it's 18x plus 12x minus 5 minus 3. So we can group those together. 18x and 12x, you just take the 18 and the 12 combined and you get 30x. And then negative 5 minus 3 would be minus 8. 30x minus 8. Good? All right, for number 8, we're going to have to do that subtraction again. So we're going to have to distribute the minus sign. I'm going to get rid of these first parentheses. 6x to the 7th minus 4x to the 5th plus 16 minus a positive 9x to the 7th. So that's going to be minus 9x to the 7th minus a negative 19x to the 5th minus a positive 5. Good. I didn't include the plus signs when they were positive because a positive subtracting a positive 9 is the same as just subtracting 9. Subtracting a positive 5 is just the same as subtracting 5. All right, let's first simplify the signs before we combine like terms. 6x to the 7th minus 4x to the 5th plus 16 minus 9x to the 7th plus 19x to the 5th minus 5. Now we can combine like terms. I see that negative 4x to the 5th and positive 19x to the 5th would be like terms, and that 16 and negative 5 are like terms, and 6x to the 7th and negative 9x to the 7th are like terms. Always include the sign in front of it. So now we have 6x to the 7th minus 9x to the 7th minus 4x to the 5th plus 19x to the 5th plus 16 minus 5. Now we'll just combine like terms. These are like. These are like. These are alike. We keep x to the 7th the same. 6 minus 9 is a negative 3. Here we have a negative 4x to the 5th plus 19x to the 5th. Negative 4 plus 19, or I think of it as 19 minus 4 is just plus 15x to the 5th. And then 16 a positive 16 minus 5 is positive 11. So our final answer here is negative 3x to the 7th plus 15x to the 5th plus 11. And you always want to make sure you have it in descending order of the exponent, right? Okay, for number 9, we're moving on to multiplication. Or no, sorry, we're not, because there's a minus sign between them. All right, so we're just distributing that negative sign or that minus sign. That minus sign is going to go to the 11 and to the negative 4z. So we have 9z minus 11 minus negative 4z is how I would write that. 9z minus 11 plus 4z. You see that? Now we can combine 9z plus 4z. Thirteen 13z minus 11. Okay, 10 is kind of a word problem, a little bit of a challenge. Subtract 3x minus 30 from the sum of negative 2x plus 10 and 9x plus minus 5. The sum of, and feel free to like Google this if you're not sure, but the sum of means plus, and subtract from means put it at the end with a minus sign. Okay, so the sum of negative 2x plus 10, sum 9x minus 5, and then subtract from. So this is what we have. We'll subtract 3x minus 30 from it. Good. You're welcome to combine these two first and then subtract, or to do it all at once, whatever you prefer. It's probably better to add these two first, right? So we have negative 2x plus 10 plus 9x minus 5. I see that negative 2x would be combined with 9x, and that 10 would be combined with negative 5. So that would become negative 2x plus 9x plus 10 minus 5. Put those together and put those together. Negative 2x plus 9x, we have the same variable. And so 9 minus 2 is just 7x. And then 10 minus 5 is just 5 minus 3x minus 30. So instead of having 1, 2, 3, 4 terms to combine with the negative 3x minus 30 plus 30, we now made it 2. So we went from 4 to a binomial, and we're just going to subtract this binomial from this binomial by distributing that minus sign. Okay? 7x plus 5, because nothing changes over here, minus 3x minus negative 30. Minus a negative becomes a positive. And then we can combine that, or we can group them. 7x minus 3x and positive 5, positive 30. We get 7x minus 3x plus 5 plus 30. 7 minus 3 is 4. And then 5 and 30 is 35. So my final answer is 4x plus 35. All right, that was adding and subtracting polynomials. Now, for multiplying, we're going on to multiplying polynomials. Before that, we just want to review how to multiply a monomial. Okay. If you have x to the power of a times x to the power of b, your answer is going to be x to the power of a times, or sorry, a plus b. It'd be terrible if I taught you that wrong. Good. You're going to see an example. If we have 2 to the power of 2 times 2 to the power of 3, that's going to be equal to 2 to the power of 2 plus 3, which is equal to 2 to the power of 5. Let's see. 2 to the power of 5 is 32. 2 to the power of 3 times 2 to the power of 2 is also 32. Okay, so when the base is the same, you can add, sorry, starting over. When the base is the same, you're multiplying two monomials. The base is the same, you can add the exponents. 2 to the third times 2 to the second is going to give you 2 to the fifth. All right, so when you're multiplying polynomials, you want to multiply the coefficients and then multiply the variables, okay? 6x times 3x squared is going to be 6, because 6x is just 6 times x, right? So that's actually going to be 6 times 3 times x squared. What is x? What is the exponent of x, or what is the degree of x? It's a degree of 1, right? If there's no number there, we just think of it as a 1. So we'll just multiply 6 times 3 is 18. X to the power of 1 times x to the power of 2 is x to the power of 3, because we're just adding them up. So that's just 18 x to the third. Good. So we're taking the coefficients. See if I can keep the colors the same the whole time. Taking those coefficients and multiplying those. We're taking the variables. And we're multiplying those. And the way that you multiply a variable with degrees is to add the degrees. X times x squared is x to the third, because that's x to the first times x squared. Or sorry, x to the first times x to the second. 1 plus 2 is 3. Good. All right, let's try another one. Negative 2x squared times 4x to the fourth. Negative 2 times 4, because we're just taking the coefficients. My coefficients are negative 2 and 4. Multiplying them. And then we're going to take our variables. X squared and x to the fourth. And combine them. Negative 2 times 4 is a negative 8. X squared times x to the fourth. We're just adding. Negative 8x to the sixth is my final answer. Notice that I did not make the x squared negative, right? The negative sign went with the 2. It did not go with both parts, okay? If there was a minus sign outside the parentheses, that would be different. But when you're splitting up a term and there's a minus sign in front of it, only one of the terms gets the minus sign. It really doesn't matter which term gets the minus sign, or which part of the term gets the minus sign, but one of them should get the minus sign, okay? Because even if I had given it, well, let's not. Multiply the polynomial by a binomial. Here we're multiplying 2x times negative 3x plus 10. We're distributing the 2x to the negative 3x and to the 10. So instead of 2x times negative 3x plus 10, we're going to say it's 2x times negative 3x plus 2x times 10. I took that 2x and I distributed it to both parts of the monomial. 2 times negative 3 is a negative 6. And then x times x becomes x squared. Right? That was x to the first times x to the first. 1 plus 1 is 2. Good. Other half of that is 2 times 10 is 20. And then that x does not need to be multiplied by anything. Good. All right, same thing here. Negative 3x times the quantity 10x minus 6. Negative 3x times 10x. Nope, we don't want to multiply. All right, how do I explain this? So it's a minus sign. Minus negative 3x times positive 6. Why did I make that a positive 6? Because I need a sign between them, right? I need a sign between them, and the sign that they gave me was a negative. Because that's a negative, I can't make the 6, or because that's now a minus, I can't make that 6 negative. You can also write it as, it is not wrong to also write it as negative 3x times 10x plus negative 3x times negative 6. Those are the same, right? So for this one, the negative sign's over here. For this one, the negative sign's over here, but everything else is the same. So you can either put a minus sign because there was a minus there, or you can put a plus sign because it just looks better, right? And that's plus a negative 6. So you put the negative over here. All right. Either way, what happens next is we multiply the negative 3 times the 10 to get negative 30, and x times x is x squared. And then we have minus negative 3 times a positive 6 is negative 18. And then x, because there was no other variable with the 6. The 6 was a constant. Good. What do we need to do now? Negative 30, x squared, minus a negative becomes a positive 18x. I feel like those were too close together. It looks muddled. Good. And then what would have happened if we had done that over here? It would have gone negative 3x times 10x. Negative 3 times 10 is a negative 30. X times x is x squared, plus negative 3 times a negative 16 is a positive 18. And then there's just an x. So you get the same answer. Good? All right. Now, here we have 6x to the 5th times 5x minus 6, the quantity 5x minus 6. We'll distribute that 6x to the 5th times 5x. I liked it when we did plus, right? Plus 6x to the 5th times minus negative 6. Times minus negative 6. I just meant times negative 6. Good? All right, let's see what happens. 6 times 5, because we're just doing the coefficients. 6 times 5 is 30. X to the 5th times x is x to the 5 plus 1, which is 6. And then here we have 6 times negative 6 is negative 36, x to the 5th. We did a plus, and then we kept that negative there. So we're adding a negative 36x to the 5th, so it's the same as subtracting 36x to the 5th. Here we have negative 10 to the 7th times the quantity x minus 12. So we're going to take negative 10x to the 7th, and we're going to multiply it by x. Then we're going to add negative 10x to the 7th times negative 12. Again, you can put the minus sign right there if you want, or you can put it as a negative right there. Either way. Negative 10 doesn't have a coefficient, or a coefficient of 1 remains negative 10. X to the 7 plus 1 is 8. plus negative 10 times negative 12 is 144 x to the 7th. It's 120, sorry. I was thinking 12 times 12. Good. All right. That was multiplying a polynomial by a monomial, but we were only using binomials. Now we're going to use a trinomial. Same exact process where you're just taking that negative 2 and you're distributing it. Distribute it to the negative 5x to the 6th, distribute it to the negative 2x to the 5th, distribute it to the positive 11. So now we're going to do it with 3 terms. We're just going to distribute that negative 2. Again, I'm going to put plus, and then I'm going to make that a negative 2x to the 5th, and then that's a positive 11. But notice that each time that 2 is a negative 2. All right, so we've got negative 2 times a negative 5. We're just taking the coefficients. Negative 2 times a negative 5 is a positive 10. The negative 2 doesn't have a variable, so we're just going to say x to the 6th, the original variable and exponent. Now, keep that plus sign. Negative 2 times a negative 2 is a positive 4. X to the 5th. Keep that plus sign. Negative 2 times 11. Now we have a negative because a negative times a positive is a negative. 2 times 11 is 22. So I'll just rewrite it once as 10x to the 6th plus 4x to the 5th minus 22. And you're done. Here we have negative 9x to the 4th times the quantity 11x to the 7th minus 9x to the 6th plus 4. Negative 9x to the 4th times 11x to the 7th plus, I'm going to run out of room, negative 9x to the 4th times negative 9x to the 6th. Right, I'm starting over. That's too obnoxious. Cannot abide it. All right, didn't want to make you watch me write all that. Now, let's just multiply. We're going to multiply the coefficients. And then we will multiply the variables. Negative 9 times 11 is negative 99 times x to the 4th times x to the 7th plus 9 times negative 9. Oops, sorry, negative 9 times negative 9 is a positive 81 times x to the 4th times x to the 6th. And we've got that plus sign again. Negative 9 times 4, 36. It was a positive 4, so it's going to be a negative 36 x to the 4th. Okay, now let's go back and combine those variables. Negative 99 times x to the 4th plus 7th, right? Plus 81 times x to the 4 plus 6 minus 36x to the 4th. Negative 99 x to the 11th. 81 x to the 10th. minus 36 x to the fourth. Oh, I forgot to mention, but just make sure after you've done all of that math that you don't have any like terms that you can then combine. So as we're doing binomials, can you combine those two? Are those like terms? No. Are those like terms? No. No, no, no. Good. Now we're going to move on to the FOIL method. Express the answer as a single polynomial in standard form. We're going to be doing a lot of this in this class. The FOIL method is first, outside, inside, last. Okay? I don't think there was a way for me to do that without in that much space. So I'm just going to move it over here. The FOIL method is first, outside, inside, last. Good. So by first, you have four terms, right? First is you're going to take that x, that first term, and you're going to distribute it to both the x and the 10. The first term from the first binomial to both the first and second term of the second binomial. So first is first times first. X times x. O stands for outside because we're going to take that first term by that second term. The two outside terms. This is outside to the left, outside to the right, right? So that'll be x times 10. Inside means we take that second term from the binomial, including the sign, so that's a positive 6. Multiply it by the first term of the second binomial, or the two insidemost numbers, and we get 6 times x. L stands for last, because we're going to take that positive 6, and we're going to multiply it by positive 10. And that's your FOIL method. So you'll simplify that. X times x becomes x squared. X times 10 is 10x. 6 times x is 6x. And 6 times 10 is 60. Good. So you take all of those, and those are all of the terms of your new polynomial. So you'll just write them in order, x squared, always with a plus between them. Plus 10x plus 6x plus 60. Because what is a polynomial? Collection of terms connected by addition. Polynomial is a collection of terms connected by addition. So we determined these were the terms from FOIL. We connected them with addition. Good. If one of these had been a negative, that's fine. You would say plus negative 6x. Now you just combine like terms if you have any. In this case, we have positive 10x and positive 6x are like terms. So we have x squared plus 16x plus 60. And you're done. This is a single polynomial in standard form. In standard form means degrees in descending order. Just like here, we have 11, 10, 4. Standard form would be x squared plus 16x plus 60, because we started with the biggest exponent, we ended with the constant. Good. All right, let's go on to 22. Oh, sorry, 21. And again, we'll do first outside, inside, last. First is going to be 5x times 3x. Inside is going to be, or sorry, outside is going to be 5x times -6. Inside is going to be -12 times 3x. And last is going to be -12 times -6. Simplify those. 5x times 3x, that's going to be 15 for the two coefficients, and then x times x is x squared, 15x squared. 5x times the -6, 5 times 6 is 30, so -30x, because there was an x with the 5, and a negative times a positive is always a negative. Negative times a positive is always a negative. -12 times 3 is 36x, but it's in fact -36. And then -12 times -6. Positive 72. Good. Then you'll just write that all again. So we have 15x squared minus 30x minus 36x plus 72. These are like terms. 15x squared, we have a -30x. We're going to combine it with a -36x. Even if they're negative, if the terms are the same, you can kind of add them and just put a minus sign in front of them. So we know it's going to be a negative sign. It's a big negative sign, bigger than 30 because it's -30 combined with -36. 30 and 36 is just 66. So -30 and -36 is just -66. We're just combining so that x is not going to change. That x would only change if we were multiplying, but we're not multiplying, we're subtracting. Plus 72. So we are done. 15x squared minus 66x plus 72. All right, for number 22, I might do FOIL, but without all in a line. So we're going to FOIL or multiply the quantity x plus 7 times the quantity x minus 7. I'm just going to go in order. X times x is first. Outside is x times -7. Inside is 7 times x. And then last is 7 times -7. Good. All right, so it was like FOIL, but I kind of did it all in one line, if you prefer that way. X times x is just x squared. X times -7 is just -7x. 7 times x is just 7x. And then 7 times -7 is a -49. So that will be x squared minus 7x plus 7x plus, darn it, sorry, should be minus 49. I'll combine these two. -7x plus 7x. 7 minus 7 is 0. So my final answer is just x squared minus 49. Good? All right. For 23. For 23, we have x plus 2 squared. This is very important. Here's what not to do. not the same, okay? We can't, for the exponent, we can't just distribute the exponent and be done. Most other things, you can just distribute it to both of the terms and be done. But for exponents, what does exponent mean, right? What does 3 squared mean? That means 3 times itself that many times. 3 to the 4th means 3 times itself. How many times? 4 times, right? So you're taking that whole thing, multiplying it by itself 2 times. So you're writing the whole thing out and multiplying it by itself. Okay? Very important that you remember that. That will come up again. All right, x plus 2 times x plus 2. First, we have x times x. Then we have x times 2. Good. Then we have 2 times x. And then we have 2 times 2. Sorry, I forgot to put all the plus signs between them. Good. So just like the FOIL, for FOIL, we wrote it out vertically. Here I'm writing it out horizontally, whichever you prefer. And then we simplify x times x is x squared plus 2 times x is 2x plus 2 times x is 2x plus 2 times 2 is 4. Now we can combine those middle terms and we will end with x squared plus 4x plus 4 for 23. Good. One more example of a quantity squared. We have 5x plus 8 squared. So that's going to become 5x plus 8 times 5x plus 8. FOIL first, outside, inside, last. Good. So our first terms are 5x times 5x. Outside is going to be 5x times positive 8. Inside is going to be 8 times 5x. And then last is going to be 8 times 8. Right here, we're going to multiply the coefficients. 5 times 5 is 25. X times x is x squared. Next, multiply the coefficients. 5 times 8 is 40. But there's one x. Because these are the same, those middle two terms are always going to be kind of the same. 5x times 8 is 40x. 8 times 5x is 40x. So the only difference was the terms were switched. They switched places. And then 8 times 8 is 64. So I'll rewrite that as 25x squared plus 40x plus 40x plus 64. Simplify that to 25x squared plus 80x plus 64. All right, for our last example today, we're going to multiply a binomial by a trinomial, okay? We have a minus 7 times a squared plus 7a minus 3 First thing we're gonna do is a times a squared. Good. And then we're going to do a times 7a. And then we're going to do a times -3. So I took that a times this one, a times this one, and a times this one, right? Now I have to do that exact same thing with the -7. So -7 times a squared. -7 times 7a. And -7 times -3. Notice that it was negative each time. Right? So we did a times each of the terms, -7 times each of the terms. A times a squared becomes a to the third. A times 7a, remember that's an invisible 1. 1 times 7 is just 7. A times a. We get 7a squared. Good. Here we've got -3 times a. We've got -7a squared. Here we're going to multiply -7 by a +7, which is a -49a. And our last one is just 7 times 3, which I was saying 3, I think is 21. Negative times a negative makes a positive. Good. So now we're going to take each of these terms. We had a cubed, 7a squared, -3a, -7a squared, -49a, and 21. And we're going to combine those into a single polynomial. Then we're going to combine like terms, and we will be done. So that was a to the third plus 7a squared plus -3a plus -7a squared plus -49a plus 21, right? Because we're just combining them with addition. Now rewrite it with plus a -3a is just -3a. Plus a -7a is just -7a squared. Plus a -49a is just -49a. And now we can combine like terms. So I see +7a squared and -7a squared. And I see -3a and -49a. So that'll be a cubed plus 7a squared minus 7a squared minus 3a minus 49a plus 21. You can combine these. And combine these. We get a cubed. 7 minus 7 is 0. So 0 times a squared is just 0. -3 minus 49, you're just combining 49 and 3 to get 52. But it's a -52 because those were both negatives, plus 21. And that is all. I think you are done. All right, guys, that is all for 1.3. Thank you so much and have a wonderful day.